as I've been telling you, as you all know, AI or artificial intelligence uh, refers broadly to a class of algorithms and programming models. Just give me a second. This is quite disturbing. I have no clue how to stop people from admitting, but this is popping up. This message is popping up. So AI refers to a broad class of programs and algorithms capable of mimicking human intelligence, including cognitive functions such as perception, learning, problem solving. So the broader aspect of AI is to build algorithms which can actually simulate human intelligence. And this specific task is applied to a wide variety of industries, include market analytics, e-com, supply chain, finance, HR, healthcare, and so on. The basis of AI is you have data in hand by which you can do some prediction. So when you talk about predictions, it is relating to some kind of regression or classification, and there are other advanced techniques also. Now, these different business segments, as I just mentioned, are by primary definition data collectors. So they have been dealing with a lot of data for ages. So they have volume of data, and they were possibly successful in applying AI ML in their process flow. But AI ML also has a lot of application in engineering industries, but the process of implementation is slow. Now, to give you an example, in manufacturing industries, for instance, AI has the highest application in process quality control. Then, of course, maintenance, which could be predictive maintenance or preventive maintenance, and the other is supply chain management, but that comes more on the management side. So when we talk about AI ML, how can we apply AI ML to improve productivity in industries? We are essentially talking about three important things. One is optimizing assets. How can we use AI ML to reduce operating costs, energy inputs? Because energy is one of the important costs going into the production. And then we also talk about reducing downtime of the equipment or increase the reliability. And then the other thing that we look into is process optimization. We may use AI ML to reduce raw material costs, improve the quality of the out products, or reduce scrap to waste. And most importantly, the people and the team working towards the implementation of this technology get to know, they capture a huge institutional knowledge. They get to know about the complex pattern of process flow from the data that are generated during different stages of the production. So these are some interesting opportunities for data-driven decision making. And here is an overview of the AI platform that is much in use in most manufacturing industries in India or in US or in any other Western parts of the world. So this shows on the left, you have these data sources. So industries connect these data sources to the platform. And the nice thing about this AI platform is that the industries help in just not connecting, and then this platform helps in contextualizing the data. And once they find interesting opportunities, they try to model the data. And once one or two models are proved to be accurate, they put it for deployment. Okay, so usually real-time data are taken inside the platform, and they are fed through a really good number of algorithms based on which the ones that are very accurate or give high performance, high accuracy, they are put for deployment. And the results are instantly displayed on the dashboards based on which the operators can take a decision if needed to control anything at the source end or at the intermediate stages. So this is how the AI platform works. Now, steel industries or steel production is a very important production process from the manufacturing point of view. This materials have served many different applications, domestic application, industrial applications, some of which includes automobile components, automotive components, then military and defense equipments, then of course marine applications such as construction of underwater marine pipes. And then you also have what you see as those electrical power transmission towers. And there are a lot of domestic uses also. I'm not going into that. And this industry has developed over the years, bringing in many new technologies, and we are expecting more new grades of steels to come up with very promising application. And this is exactly where industries can create value to integrate AI ML into their operations. But again, the process of implementation is very slow. Now, the areas in steel production where AI has already penetrated in are mainly, optimizing cost. Then, of course, process quality control, which includes composition control. That means monitoring the composition during end-to-end production, and also detecting defects early before they become a problem. Now, I'll quickly take you through the steel making process. For those who know, just bear with this. And this is something I guess all undergraduate students across any parts of the world have come across. This is a very unique process, the traditional blast furnace process. And So steels, as you know, are classified into clean carbon steels and their alloyed counterparts, and also stainless steels. Typically or traditionally, this process starts in a blast furnace where the raw material like iron ore, coke, pellets, etc., are added from the top. And at the bottom, you have this hot molten material containing around 4% carbon. Okay, so this process is usually assisted through a series of reduction and carburizing steps. And in the next step, we transfer this hot molten material into the basic oxygen furnace, where it is further decarburized to the required carbon content and then transferred to the ladle. From the ladle, it is poured into the mold through this tun dish. So what we get at the end, basically slabs of relatively much lower temperature than the parent liquid steel. And the slabs are further processed into semi-finished products, which are used to produce the flat and the long product. So this is the working chain. Now, the selection. So my today's lecture is specific to material selection. And the selection of this semi-finished grade of steels is heavily reliant on the talent or the knowledge of the process engineers and metallurgists who make certain decisions based on certain properties or certain factors. Now, the selection of this semi-finished grade of steels comes through extensive R&D experience and practice, but this is quite time-consuming, labor-intensive, and also cost-intensive task. So the obvious question that arises is, can AI-based techniques help in kind of initially screen the different grades of steels based on certain known properties? And further to that, can AI-based techniques help in predicting the class to which an out of the sample steel, or what you call as unknown grade of steel, belongs to? Okay, so the answer to that is yes, as long as you have 1 or 2 years worth of data and sufficient sample size, and that the production has been tracked end to end, it is possible. So we come up with a few different AI ML-based algorithms, such as clustering algorithms that can help cluster the different steel grades into different groups or subgroups. And once those classes are identified, we further develop or build predictive algorithms, which can help predict the class of any out of the sample or unseen sample. Okay, so finally, we actually select 1 or 2 models based on highest model accuracy and performance for deployment.